In problem 34, we want to find an equation of a line that's tangent to the graph f, in this case 2x squared, and it's also parallel to a given line, and the line is 4x plus y plus 3. So we're going to take a look at this on the calculator first and then see what it is that we're looking for. And I want to graph both of those equations there. 2x squared is no problem, but 4x plus y plus 3, we'll have to solve that for y to enter that into the calculator. But that's not too difficult. In this case, it's y equals negative 4x minus 3. Okay, then to see what it is that we're looking for here, I'm going to graph both of those functions. Go into y equals, have 2x squared, and y equals negative 4x minus 3, and zoom option 6, standard, and I'll take a look at those. So those almost look like they're tangent there, but they're not quite. So what I'm looking for is a line on the a tangent line to the original curve that's going to be parallel to the line that's drawn there. And if I zoom in a little bit, so I'm going to change my window negative 5 to positive 5 for my x values, and let's see if that gives us a little bit clearer picture. So they're not tangent as it is, but I'm looking for a line right in there, and I'm going to assume it's right around negative 1 x value that this is going to happen. So I'll put the graphing calculator away, and we'll go to find the derivative, the slope of the tangent line for 2x squared. Now in this case we don't know the specific x value. We could guess, but we don't know the specific x value that we're looking for, so we have to leave this in a general form. We're looking for the derivative of f prime of x, and that's going to give us a function, not a specific value. So we have the limit as delta x approaches 0 of f of x plus delta x minus f of x over delta x. Plugging in, we get limit as delta x approaches 0 of 2 times x plus delta x. Wherever we saw x in the original function, we simply replaced it with x plus delta x. Then minus f of x, which is 2x squared, and all over delta x. The only thing we need to do here is expand out the x plus delta x quantity squared, and that will be x squared plus x squared plus 2x delta x. I'll write it out, leaving it in parentheses because we still have to multiply everything by 2. So expanded out, that's x squared plus 2x delta x plus delta x squared, whole thing times 2, and then minus 2x squared at the end, and still all over delta x. Now I just need to multiply 2 and then simplify, and we had 2x squared plus 4x delta x plus 2 delta x squared minus 2x squared over delta x. Now when we find the zero pairs, everything without a delta x should disappear. We factor out a delta x, and if you'd like, you can start canceling there. So we cancel out a delta x from each term in the numerator along with the delta x in the denominator, and that simply left 4x plus 2 delta x. Plugging in delta x is 0, we only get 4x. And that is the function that will give you the slope of the tangent line to 2x squared for any value of x that you're looking for. Now then, what are we going to do with that? Well, going back, we're looking for a line that's parallel to the line negative 4x minus 3. Well, the line negative 4x minus 3 has a slope of negative 4. So what this is saying is that where on the curve 2x squared is there a point that has a derivative equal to negative 4? Because there, the slope of the tangent line will be negative 4, and that tangent line will be parallel to any other line that has a slope of negative 4, including this line here. So all we need to do with this is set our derivative 4x equal to the slope of negative 4, and we see that that only happens when x is equal to negative 1. So if we bring the graphing calculator back in, and we're going to graph a tangent line when x is equal to negative 1, you're going to see that that would be negative 4x minus 2. And I'm going to run out of time here, but I show how we find that tangent line.